Okay, this video is going to go over in-class example number 6, which reads, a 2 kilogram object is attached to a 1.5 meter long string. 2 kilogram object, 1.5 meter long string, and swung in a vertical circle at a constant speed of 12 meters per second. The question is, what is the tension in the string at the top and at the bottom? So this is actually two separate problems. One's for the top and one's for the bottom. Let's identify some of the things that we know. All right, so we know the 2 kilograms represents the mass of the object. The 1.5 meters represents the radius of the circle that it's going to make. The 12 meters per second represents the velocity. Okay, and we need to find two things. We need to find F tension at the top and F tension at the bottom. Okay, first thing I'm going to do is draw a couple of pictures so I can sort of visualize what's happening. So let's look at the top first. So this is the top. So I have a circle. Well, here's my ball. It's on a string. And it's going around in this circular path. Okay? So that's the path it's taking. Like, we'll pretend that it's going this way. So if I'm looking at the forces here at the top, I'm going to have the acceleration, first of all, is going to be centripetal acceleration, which is towards the center. Okay? I'm going to have an FG downwards, and my tension, always remember the tension is parallel to the rope and away from the object. Parallel to the rope and away from the object. So you'll notice that my acceleration, my FG, and my tension are all going in the same direction. Okay? So I'm going to set up my net Fy. Net Fy will equal MAY. I can't say my MAY is 0 because I have a velocity in a circular path, which means I do have an acceleration. So I'm going to, since my tension force and my weight are both going in the same direction as my acceleration, I'll show you again. My tension force is going down, my weight's going down, my acceleration's going down. That means those two forces, the tension and the weight, are going to be positive because they're moving in the same direction as the motion. Okay? So I'm going to say Ft plus Fg, both going in the same direction, equals m, and I know that my centripetal acceleration is going to be v squared over r. We've already learned that that is the equation for acceleration. Okay? If you're more comfortable solving for the acceleration separately and then plugging the number back in here, please feel free to do that. I'm just going to use just this one big equation. Okay? So I'm going to plug my numbers in. This is going to look like this. Ft plus Fg is going to be the mass times 9.8, 2 times 9.8, equals the mass 2 times v squared, 12 squared, over r 1.5. Okay? And so I can use some math to find tension. Go ahead and pause the video, solve for the tension. And you should get for the tension 172.4 newtons. Okay? So that's for the top. All right, now let's solve for the bottom. Let's see if the tension force at the bottom of the path is any different than the tension force at the top of the path. Here's my ball on a string. This time the ball is at the bottom of the path. And I'll draw the dotted line to represent the circular path that the ball will follow. We are going to indicate now that acceleration, do it in green, acceleration is now towards the center of the circle, which will be upwards, okay? And if I'm drawing my force diagrams this time, remember that FG is always down towards the center. But this time, tension force is away from the object, parallel to the rope. Away from the object, parallel to the rope. So now, when I want to set up my net Fy, I'm subtracting the tension from the Fg. Now, since the tension here and the acceleration are going in the same direction, I'm going to make the tension the positive force because it's going in the same direction as acceleration. So Ft minus Fg equals MAY. Now remember, the acceleration is centripetal, just like the previous problem. So we're going to plug our numbers in. Ft minus 2 times 9.8 equals 2 times V squared over R. Okay, plug your numbers in. I'll plug these numbers in here. 12 squared over 1.5. That the only difference is that you're subtracting the forces instead of adding the forces. Pause the video, solve for the tension force, and you get 211.6 newtons. So you can see there's a huge difference between the tension force at the bottom of the path, of the circular path, compared to the top of the circular path. Because at the top of the circular path, Fg is helping you move, is helping the centripetal acceleration. At the bottom of the path, Fg is hurting the motion towards the center because it's in the opposite direction.